So today we are going to be learning about hydraulics and how the force from a smaller piston can translate to a larger force with a larger piston. So looking at this example, a hydraulic lift has 2,000 newtons applied to an input piston that has an area of 50 centimeters squared. The output piston has an area of 200 centimeters squared. So the first question is, what is the pressure on the liquid exerted by the input piston? So in our last unit, we learned about how to solve for pressure. So pressure equals force divided by area. So it's asking about the input piston, so that means we care about the force applied to an input piston that has the area of 50 centimeters. So the area of the input is 50 centimeters squared, and we also know the force is 2,000 newtons, and that is the input. So the pressure is 2,000 newtons divided by 50 centimeters squared. So let's do that calculation. So that gives you 40 newtons per centimeter squared. So now that would be your answer for the first one. Now, for B, it is asking will the force on the output piston be the same or less than the force exerted by the input piston? Explain. So, will the force on the output piston be the same or less? So since this is a hydraulic lift, we know that the pressure is spread out evenly. Because this is a closed system, no liquid is escaping. So to figure out if the force will be the same on the output piston, we will do a ratio. So the ratio is the force of the small piston divided by the area of the small piston is equal to the force of the output piston divided by the area of the output piston. So we already know the force of the small piston. It is 2,000 newtons. We know the area of the small piston. It is 50 centimeters squared. And we also know the area of the output piston, or large, if you want to do small and large. So that is 200 centimeters squared, right there. But we don't know what the force of the large is. So we are just going to input those values, and then we will see what it equals. So 2,000 newtons divided by 50 centimeters squared equals FL 200 centimeters squared. So to get this one, we will multiply each side by 200. So then those will cancel out. So 2,000 divided by 50 times by 200. So when we do that, it equals 8,000 newtons. So we are multiplying that side, so that cancels out our centimeters squared, leaving just newtons. So the force of the large is 8,000 newtons. So will the force on the output piston be the same, greater, or less than the force exerted by the input piston? Let's explain. So looking at our calculations, you can see that the force of the output piston is going to be greater. And that is because the small input piston is moving a larger distance with that force, while the output piston is only going to be moving a small distance because that 8,000 newtons needs to be spread out over 200 centimeters squared instead of just 50 centimeters. So the force is going to be greater, but it's going to be traveling a smaller distance.